today's the 3rd, right? In 2 days, it will be Cinco de Mayo, and we can all and then we don't have to go to school on Friday, so we can just spend the whole day eating tacos, which is so rad. Yeah. So today you're just going to practice the fine art of multiplying and dividing rational expressions. Almost ran myself right out of real estate there. So you guys remember way back, this is not on my note card. It just occurred to me that I should probably say this. You guys remember back in like many, many years ago when you first learned how to do fractions, you might have had to do problems like 15/8 times I don't know, like 12/25. So the reason I'm bringing this up right now is not because I feel like teaching you a lesson on 4th grade fractions, but rather just to bear in mind that as we work today, we're going to use the same ideas that we used back in the day. And whoever taught you fractions, I hope, taught you that you should not multiply 12 and 15 and 8 and 25. Because what's going to happen is you're going to get a big number over a big number, and then you get to reduce that. And no one wants to do that. So someone taught you that when you have a multiplication problem, you actually want to reduce the parts and pieces that you can before you multiply the fractions together, right? So the first thing that we want to say is that anything from the top can go with anything from the bottom. And that means you can reduce vertically or you can reduce diagonally. The only rule in play is that you cannot reduce anything from the top with anything else from the top. That's cheating. And then, because then you're smacking the problem double on one side. And so we got to keep the fair's fair mentality here. So what would you see in a problem like this? Right. So if you think about it, like this 15 is really a 3 times 5, right? And this 25 is really a 5 times 5. And I'm writing it this way because this is kind of more what it'll feel like today when you see parts and pieces that are out and factored and exposed. So then I would say like, oh, so the purple things both have 5s. So I could like take out this 5 and take out this 5 because one's on the top and one's on the bottom. And what do you think about the 8 and the 12? Right. And so if I wanted to think of it correctly, I could think of this 8 as 4 times 2 and this 12 as 4 times 3. There's lots of other ways I could have done that, but I chose that way because I wanted to expose common factors. And so again, I would say, oh, there's a 4 on the top and there's a 4 on the bottom. And then the factors that remain are what we mash together. So like I have a 3 and a 3 and a 2 and a 5. And there's no one left from the top that can reduce with anyone left from the bottom. So our answer would be 9/10, right? You remember this from way back in the day? Okay. So if you ever find yourself with fractions, that's just a pro tip. You should always reduce before you multiply. Otherwise, you're going to have a little bit of a mess on your hands. So anyways, having said that, this is what we're doing today. If you want more examples, please. If I'm reading this the wrong way and we do a couple and you're like, whoa, what just happened? Just say it and I'll whip up some more. So today's work will be nice and pleasant. There are no like sums and differences of cubes. There's no short sets and long sets. It's just all going to be like quadratics and linears, basically what you should be super comfy with. So step one, like I showed you in that last problem, is to think about factoring all the parts and pieces. So while we're here, let's get in there and factor anything that could be factored, such as the top left. So if we look at the top left, I hope it's obvious. What does he factor down into? Good job. So that's x minus 5 and x plus 7, right? So you can replace, just like you've been doing with rational expressions. Anything can be factored, just factor. Because that's all we're trying to do is expose parts and pieces that can cancel other parts and pieces. And then what else do you see?
The top right. X.
Nice. And I just decided to start, I don't think in all the years I've been teaching this, I've ever had my first example be a division problem, but I thought, let's just go for it. What do you guys remember about dividing fractions? Copy.flop, right? And so before I can actually do what I want to set out to do, and about half the problems today should be division. I didn't count them, but it'll be roughly half. And so with division, you just got to catch yourself and remember to do the switch the second fraction one. So I'm going to leave the first part alone. So it's going to stay as x minus 5 times x plus 7 over x minus 6. And then I'm going to change the problem to multiplication. And then I'm going to flip the second fraction over. So it's going to be 3 over x plus 7 times x minus 2. And you probably know exactly where I'm headed with this, but yes, just like I did with the little baby fourth grade problem, I'm going to look for parts and pieces that can reduce parts and pieces. And it's pretty obvious that we have an x plus 7 on the top and an x plus 7 on the bottom. And I don't know why I didn't put my last parenthesis there. There we go. Wasn't going to sleep today. Do you see anything else at all? Nope. And some problems will just kind of be like this, where you just get you know, a lot of progress that gets made. Progress is progress, and sometimes it's grander than other times. But in this case, what I'm going to do now is the mashup. And once you've milked out all of the common factors, you just mash it. And so the top of my answer, and I know, by the way, that this is going to be my final answer because I have visually verified that nothing else can go bye-bye. So you don't have to worry about anything after this step as long as you've done this step thoroughly. So the top is just 3 times x minus 5. Parentheses are needed there because that's a quantity being multiplied. And then we're going to put it all over. Parentheses now need to be introduced to the x minus 6 because he's going to multiply by the x minus 2. And that's that.
If the x minus 6 was a 6x, then would you simplify that down?
Excellent question. Yes. So does everyone have this in their notes now? Because I'm going to mess with it to answer Alyssa's question. She had asked if instead of x minus 6, so let me get rid of this this answer here. So if instead of what it says here, if that bottom had said like 6x instead, and I think I might have gotten my point across to you. I don't know how it happened, but you guys seem to be okay with not trying to cancel things that are parts of pluses and minuses. I think you get that. But this 6 up here is no longer part of a plus or a minus, right? He's now what we call a factor because he's multiplied by x. So at this point now, you could take this 3, he's just a solo factor, and this 6, who is a factor, and you could now reduce them like a kid would, like a little kid. So I could take them and divide them both by 3, making that a 1 and making that a 2. See how different that would be? So again, when something's bound up and wrapped up in its own little addition or subtraction, ooh, it's off limits. But if it's a multiplication piece, then it's hunting season, right? Does that make sense?
Yeah.
Okay. Any questions on that first one? All right, let's do one more. And again, if you want more, please just let me know. So for this one, we have 20 minus 4n over 4n times 1 over n minus I. Anything tempting you? What about it? You can be proud when you say stuff like that. First off, were any of you tempted to cancel those 4 n's? Awesome. Awesome, awesome, awesome. Because that was supposed to look delicious when I wrote this a few minutes ago. Like, I was hoping that you'd be like, oh, thank you for not saying that. Because that 4n on top is like spoken for, right? He says, I'm part of subtraction. Leave me out of this. But Bryn is exactly right. So what catches our eye is that in this upper left-hand corner, first off, you notice the order's kind of wonky, right? We've been practicing this, that it's kind of backwards. So what we want to do is we want to pull out -4. Because the pulling of the negative, remember, causes the order to switch, and it gets us gets our expressions to go in standard form. So if I pull out -4, what's left?
And minus 20.
n minus
5.
5. And it's at that point where you realize, wow, I'm really glad I've got mad skills because I'm seeing something now that I wouldn't have otherwise seen. But by doing what Bryn said and getting that thing into the proper order, I now have exposed a factor. And again, n minus 5, you might say, well, that's a subtraction. Yes, I get that it's subtraction, but it's its own entity. And this n minus 5 in these parentheses can cancel this n minus 5 because that n minus 5 on the bottom is an entity. If it makes you feel better to put it in parentheses to make it kind of feel more visual, then do that. But anyways, the n minus 5s both cancel each other out. So I'm left now with 4 factors. I have a -4, a 1, well, 3 factors, I guess. Well, 4, and a 4, and an n. See any progress? What? You can, because they're both parts of multiplication problems. And that's the kicker. If you're part of multiplication, you are cancelable. You are what we call a factor. And factors are always in season. So yes, I can take that -4 and I can kill it by 4, leaving it as just a boring -1. And then I can, of course, just vanquish that entire 4 on the bottom. You see, just chipping away. Is there anything else that we missed? So let's go through now and kind of take stock of where we are. Who's alive still on top? -1, and who's still alive on bottom? And so our answer should be written as -1/n. Who'd have thunk that it would come out like that when you look at the original? But it's just, you just chip away at it, man. You factor the parts that can be factored. If it's division, you flip it to times and then do your thing. And you can flip it up. You could flip before you factor, or you can flip while you're factoring if you want to save time. You know, who cares? You feel like that's okay? Can you do this? Factor, 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 and cancel. That's it. All right. Well, I'm going to stop the recording. Actually, what I'm going to do is pause the recording. And then if you guys have questions, then I'll start the recording back up again and get your questions on. Here's problem 1. And if you're watching this recording and you can hear Neil Diamond in the background, consider yourselves lucky. By the way, this song was from what movie? Inspired by what movie? Who has a heart light and took a ride across the moon? E.T. Very good. Oh, I got to. All right, resuming recording. So question 1 just came right out, and so this proves that maybe I didn't do enough examples in the lecture. So we'll do a couple problems together, and we'll consider this like a continuation of. Does anyone know a way to take 2 MP4 files and connect them into one video? Can I do that? I can edit them together into just one. I'll try to do that before I post it so that people don't have to watch 2. All right, let's do this. Question 1. The first thing I see is that in the upper left, it is absolutely dead. There is no GCF. It is not backwards. And for the love of God, the 2n and the 9 are off limits independently of each other. The only way either of them is going to go bye-bye is if collectively as a team elsewhere in the problem, we can find another exact copy of 2n minus 9. 2n, you can't cherry pick. Minus 9, you can't cherry pick because they're parts of a subtraction problem. So let's get that out of the way first. So having said that, let's go attack the 3 things that need factored. Let's go ahead and start down here on the lower left. What do we get? What can we do?
Take out 8.
Yeah, for sure. So I'm going to take out 8 and I'm going to take out n. Sometimes the best you can do as far as factoring is concerned is just pulling a GCF. You know, you get what you get. And what will be left when I take out 8n? Well, all B. Look at that. So we just found a copy of the guy up on top. So I'm going to color code some parentheses for your educational convenience. So now my lower left hand is replaced with this. And let's proceed to the upper right hand corner now. what can I do up there? Pull out an 8. And there's an N, and I didn't copy it down right. So yes, there is also an N up here. So what I can do is I can pull out 8N. And what does that leave behind?
N minus 8.
Excellent day. And so again, what I like to do, since you probably do it different from me because you don't have this magic cut and paste technology, but take the old one out and put the new one in its place. And then finally, what can I do with the lower right-hand corner? I can pull out a 4. And what that's going to leave behind is N minus 8. This actually is a very fruitful problem because it turns out there's actually a boatload of stuff in this problem that can go bye-bye. As long as we follow the rules. Remember, things can only go bye-bye when they're multiplication pieces, but there's a lot of them here. So let me clean this up a little bit, and then we'll get to the fun part of the problem, and that is the slaughter fest at the end. So here we go. I'm seeing a bunch of stuff. I'm seeing, first off, that these two N minus 9s can kill each other off. What? You can do it if it's an entire chunk. You cannot cancel the 2N with the 2N. You cannot cancel the 9 with the 9. But that's why I put them in. That's why I put them in those red parentheses for you, so you can see it's a factor. Again, I'm not killing anything independent like by itself. The whole thing together kills the other whole thing together. And that is the hardest part of this unit, is to get your head around that. What else do you see?
8N.
Yeah, this entire 8N, because 8 and N are factors, they're multiplied, can kill this entire 8N. What else do you see? The N minus 8 and the N minus 8. And I'll tell you what, the only man left standing is 4. Perfect, Brooklyn. So the answer is 1/4. And remember, the 1 doesn't show up necessarily anywhere. We put it there, though, because we know that a fraction can't be a fraction if it's empty over 4. That's just creepy, right? Would you like to do another one? Let's do number 2 together also. Yeah. So I'm going to copy number 2 down, and I'm going to, by gosh, I'm going to do it correctly this time.
Can we just do copy that?
Yeah, I'll dot flop it as I copy it. So if you're working on separate paper, you should dot flop so you don't have to, you know what I mean? Copy dot flop so you don't have to rewrite it over and over and over again. Yeah, I'm going to make these videos go together, and we'll just consider this like a continuation of the notes because I underestimated, I think, what you were maybe up against here. So when I change the problem 2 to multiplication, that means that what used to be on the bottom is now going to go to the top. And then what used to be on the top is now going to go, of course, to the bottom. Whew, I think I got it copied down correctly. And now it's just Factor Fest 2023, baby. Here we go. Let's go nice and organized. Let's start in the upper left-hand corner. What are we going to pull out of that?
Nothing.
There should be at least one thing that you pull out. The negative. Thank you. We never want to head into a factoring problem with the leading coefficient being a negative. So what I am going to do is I'm going to pull the negative and look at it as now 35k squared minus 67k plus 30. And your spidey sense ought to be telling you that that's not done. Like there's, you know, that that's going to be a factorable trinomial. The computer generally doesn't just generate a bunch of nonsensical garbage. So this is probably a factorable trinomial. So when I think about factoring that, I think about that it's probably going to be a 7k and a 5k. What do my signs have to be? Two minuses for sure. There's no doubt about that because they multiply to make a positive 30. So they have to be the same. Minus in the middle. And I will say that if you struggle with this, like, I hope I don't lose you. You're going to think I'm crazy, but not like that would be the first time you thought I was crazy. I'm going to stop right here and I'm going to go somewhere else because I want to show you, and I alluded to this yesterday, but I don't think it really made sense, but it should now. I'm going to go factor something easier, and I bet I have a hunch it's going to give me a clue. So having said that, let's head down now to the lower left-hand corner. And what kind of factoring is this down here?
Just take off that.
That's just GCF, right? So let's pull out a 6. And what does that leave behind? So this is a pretty cool strategy for you because now that you've cleaned up the lower left hand, the math gods are trying to throw you a hint here. They're trying to say there's probably a really good chance that you're going to see another factor like this purple one here. You're probably going to see another copy of him somewhere else, which tells me then when I go back up to the top that I'm thinking maybe, just maybe, that I should put a 5 here to get that factor to match the one below it. And then that inevitably means I have to put a 6 here. And it works. So factoring like that can be difficult, but when the whole problem is kind of working together as a system, then you can find little clues scattered throughout. Do something easy and it helps you do something hard. So I am going to get rid of all of this. And then stick my negative back on there and move all of this now into position. So far, so good. All right, let's head to the upper right-hand corner. And this is pretty light work, I think. What do we see in the upper right-hand corner? Pull out a what? There you go. So if we pull out a 3K, what does that leave us with?
7K plus 5.
And me thinks that maybe, just maybe, we just found ourselves another clue for what could be, for some of us, a difficult situation in the lower right-hand corner. But now that I have a clue there, I have a feeling that maybe, just maybe, this bottom section, one of his factors is going to be 7K plus 5. Not a guarantee, but it's certainly a great helping hand to start. So what would my other factor have to be?
5K.
So let's verify that that does in fact work. If you do the 2 in the middle, you get 25K. The 2 on the outside are negative 42. Sure enough, 25 minus 42 is negative 17. So again, we're using clues from elsewhere to save ourselves time. So I'm going to get rid of this old stuff here. Zoop, and put the good stuff in his place. And that is what this problem should look like when it's all stripped down to its bare like DNA. Now what? Cancel, right? The slaughter fest. So I'm going to take this 7K minus 5 and this 7K minus 5 and this 5K minus 6 and this 5K minus 6 and this 7K plus 5. Holy smokes. I'm still not done. This 3 and this 6 can both be divided by 3, leaving a 1 and a 2. And the only dudes left standing, I'm going to circle them in green, are this negative sign, this K, and this 2. Wow. That's the definition of a fruitful endeavor. So yes, the answer is definitely negative K over 2. You guys feel like you're okay, or you want to keep going? You good? All right. This time I will just pause the recording and I will not stop it, no matter what.